Okay, so welcome everybody to another GCSE booster session. What we're going to be covering today is laws of indices, then some equations with indices, and then sine and cosine rules, including finding the area of triangles, and then some bearings as well. So if you have any topic that you would like me to cover, please put it in the chat. Make sure that you have your calculator handy, as we're going to be using trigonometry. And this session will be recorded, and then what is recording it now, and we'll upload it to the YouTube channel. You can access it at a later stage. So, as I said, we started with the laws of indices. Now, I decided to include this. This is the first page of the first booklet, so you can see that when you start your A level, you start with the laws of indices. So it's a very good thing that you get strong on this. So we're going to start with this starter. So for those of you who have joined later, maybe give you a couple of minutes to go through these ones. And as I said, oh, sorry, there's somebody else. So, okay. Hi, Emma. Hi, Saya and Summer. So, so as I said, just next questions, and then we're going to be going one by one. Okay. So just waiting for some more people to arrive. So get my calculator at the ready. Where's my calculator? Is here. So make sure that you've got your handy. Okay. So as you can see, we're doing this starter on indices, and as you can see, you got a to the power 5 by 3. So when we've got power of a power, all we have to do is 2 times the exponent. So that is just a to the power 15. Now, because we've got a bracket here, everything inside the bracket has to be raised to the power 4. So we can access 2 to the power 4. So we can remember what we've done, a to the power 4. So 2 to the power 4 is 16. The answer to that is 16a to the power 4. Here, you can see that we've got minus 2 to the power. So we're going to be very careful. We're always careful with the sign. So we're going to write minus 2 inside the bracket to the power 4. And then we've got bracket. So we got power to a power. So that's going to be a to the power 8. Now we have to be careful with this first one, because remember that if the is odd, a negative to the power odd is a negative, whereas a to the power even is always a positive. So we have to be careful with that. So let more people. Hi, Holly, welcome. So as I said, we're going to do this question. So we've done minus 2 to the power 4, that is 16, and then a to the power 8. And then here we've got 3 things to the power. So we can just write 3 power 3, then a squared to the power 3, and b cubed to the power 3. So 3 to the power 3, 3 times 3, 9 times 3, 27. A to the power 2 to the power 3. So remember, of a power, we times them. So it's a to the power 6, and then 3 b cubed to the power is 3 times 3, 9. The most common mistake is confusing this one with that one. So the way to remember in this actually is if you think of x squared, so x squared times x cubed. So the easiest way of remembering, if you got x squared and here x cubed, you've got 1, 2, 3, 4, 5. So you add them together. So this is the easiest way of remembering that. So not confusing it. And then the next one, we've got cubic root. So the first thing that we do, we use the Sixth law. So we're going to write that as 64 to the 27 v to the power 15, and then because it's a cube root, we write it to the third. So as soon as you see a root, you put that in the denominator. So you're just learning that. So then we've got 64 to the power of a third, or the cube root. Then we've got t27 to the power of a third, and v15 to the power of a third. So the third root of 64 is 4, because 4 times 4 is 16. 16 times 4 is 64. So that is 4. Then we've got 27 times is 27 divided by 3, which is 9. And v to the 15, 15 times a third is the same. Divided by 3 is v to the 5. Okay, so a little warm up to see how we are with the indices. Now I'm going to give you a couple of minutes now if you want to think about put them as powers of 2. So you may have done things like this before. This is going to be very, very useful for solving equations. So if we think of how we can write 8 as a power of a number, probably know that 8 is the 2 cubed, 2 times 2 times 2. 1, a fact that anything to the power of 0 is always 1. But in this case, because they're asking us for 2, we just write 2 to the power 0. Now here, we've got 1 over 2. So when we've got 1 over, always negative powers. So 1 over 2 is 1 over 2 to the power 1. This is the same as 2 to the power to the minus 1. So this is an important one to remember. When you've got 1 divided to a to the power n, whenever you have something in the denominator is a negative power. This is a very important one to know. Root, remember that a root like that is a square root. So a square root is the same as 2 to the half. For this one here, we're going to write it as 8 to the half. Okay, because it's a square root. And we know from before that we can write 8 2 to the power 3. And using the law we have used before, we've got a half, which is 3 over 2. So remember that if you do 3 times is the same as having 3 over 1 times 1 over 2. So you multiply the tops and multiply the. Don't forget your fractions. And then here again, you've got 1 over root 2. If you want me to put all the steps, then root 2 is the same as to the half. And remember, because it's underneath, is a negative power. So we write it to the power of minus a half. Okay, so I'm going to be using these a lot in the next question. So this is just the lots of indices, and the request last week was about solving equations with indices. So the trick, if you want the trick, to express both sides with the same base. So this is the trick. So obviously the left hand side, I've got 3, so I'm just going to write it 3 to the power x plus 1. But of course, I would like to use that very same base there on side. So 27 is the same as 3 to the power 3. And then I've got that to the power x. And underneath I've got 9, and 9 is the same as 3 square. So that's the first step. Now the second thing to do is to apply the laws of indices. So the left hand side is the same. We've got 3 to the power of 3x, because we multiply the powers, divided by 3 square. Then we have 3x plus 1. And remember, when you've got a power divided by another power, you take away the exponent. So that's going to be 3x minus 2. So when with two things that are the same with the same base, okay, they got the same base, that means that the exponents are same. So when you've got the same base equal, the powers have to be the same. X plus 1 equals to 3x minus 2. And then we have an ordinary linear equation, and we can gather the x's to whichever way we want, but I'm going to move the x's to that side. So it's going to be 3x minus x is going to be 2x. And then I'm going to send the minus 2 to the other side. And I'm sending the x to that side. I'm sending the minus 2 to that side. So when I go to the other side, it goes as a plus 2. But you can add 2 both sides. So then I can divide by 2. So x is equal to 3 divided by 2. So we're doing now the next question. And here we've got, you can see 25 and we've got 5s there. So we're going to try to put everything as a power of 5. So 5, I can write that as 5 squared to the power of x minus 1. And then I can write that 5 and then 5 to the half. So see if you can do the next step. I'm going to give you a couple of minutes and see if you can anticipate the next step. Those people watching this on the video, you can pause the video now. Okay, so now we've done that, so you can see that you've got we got 5 squared to the power x minus 1. So we multiplied the power, so we've got 5 to x minus, and then on the right hand side we've got 5 is the same base, and then we add the exponent, so it's 1 a half. So somebody's waiting in the lobby, just carry on that. And so as I said, we have, as you can see, we've managed to put both sides as powers of 5. So what we can do is now write the two exponents are the same. So we've got the exponent 2x minus 1 is equal to 1.5. And remember that we can write 1.5. I'll leave it indicated here, 1.5. But remember that 1 is the same as 3/2, 2/2 at 1. So we can, as we got 2x minus 2 is equal to 3/2. So 2x equal to 2 at 3/2. So we can just write x. And then to do these fractions, remember 2 is the same as 4 divided by 2, or multiply that across. 4 at 3 divided by 2. And finally, we can divide by both sides by 2. So I've got 7 at the top, and then 2 times 2, 7 divided by 4. So we're going to do another example of this type. Now, you can see that we've got 16, 2 and 2. So of course we know that 16 is 2 to the power 4. So we are going to write everything in terms of powers of 2. So we know that 16 is 2 to the 4. So we've got 2 to the power x divided by 2 to the power x minus 1, and that is equal to 2 to the half. So I'm going to give you a couple of minutes to see if you can anticipate the next steps. And if you're watching this at home, the video, just press pause now and see if we can. As you can see, we've got in the numerator, we've got 2 to the power 4 to the power x. And we know that when we've got power, we multiply the exponents. So it's 2 to the 4x. And then I've got 2x minus 1 equals to 2 to the half. On the left-hand side, we have a power 2 to the 4x divided. And remember that when we do that, we take away the exponents. So we have 2, and then it's 4x. Careful here, because we're taking away all of that. So we have to use a bracket. So it's 2 minus x minus. Be very careful with that, because we're taking all of that away. So that is 2 to the half. And then remember, because we've got everything, we've got 2 to a power equals 2 to a power. That means that the powers are the same. So we can write 4. Then we can do all of that. Minus x at 1 is equal to a half. And then we have 3x plus 1 is equal to a half. And we can do this. I mean, there's different ways we can move the one to the other side. But usually what we do is, if we've got any equation and we've got a denominator, and multiply all the equation by that numbers, multiply both sides by 2. You've got 6x equals 1. So 6x is equal to, remember 2 goes to the as a negative, so you go minus 1. So x is minus 1/6. So moral of the story is that whenever you have something like that, you try to put both sides with the same base. So this one is very similar. So we just do this one. I think I've got another one there, so we can just finish with this one now and move on. So 8, remember, how can I write 8? Well, 8 is 2 to the power 3 and is to the power x plus 1. I've got 2 to the power x there. 16 is 2 to the power 4. Then I'm going to use indices. So I've got 2. So remember, 3 is going to multiply to the whole thing. So probably it's good habit to put things in brackets so we don't forget that. So it's 2 to the 3x plus 3 divided by 2 to the x equals 2 to the 4. And then remember, let's use the laws of indices. So a power divided by another power with the same base. So remember, we take away the exponents, x plus 3 minus x 2 to the 4. We've got the same base equal to each other, so the exponents are the same. So we can do 3x minus x is 2x plus 3 is equal to 4. 2x is equal to 1. So x is equal to a half. And similarly, in this case, we would write 3 to the power 3. And we'll do this one similarly. So hopefully when you see one of these questions in future, you will know what to do. And same with this one, we will have to put everything as a power of 2. Okay, so so now we move into the sine and the cosine rule. This was another thing that, and I use this mnemotechnic rule that if we got that's like a beak. So if you know adjacent sides and the angle in between, you use the cosine rule, which remember is c squared is a squared plus b squared minus 2ac, and the cos of that c. Okay, so if we call this c, remember the opposite like that, and then we've got and b. So c squared is a squared plus b squared minus that. And we use the sine rule when we know the alternate. So if we know, for example, one side and the opposite, or another side and the opposite angle, and as you know, is sine A divided by A equals to sine B divided by B sine C divided by C. And this is a handy formula to know as well. Then when we know the angle in between and two adjacent sides, the area of a triangle using this formula. So make sure that you've got your calculator handy, and we're just going to do a few examples of with the sine and the cosine rule. But remember that quack is something that I used to remember. So in this case, we got angle, and so we know that angle. We know this angle, and we want to work out the length. So this is what I need to find out. BC. I know. So I know this side here, right? 15. I know the opposite angle, and I want to find that one, but I know this one. So remember, it's alternate. So this is going to be a sine rule thing. Okay. So as you can see, BC. So if we apply the sine rule, it's going to be BC divided by the sine of the opposite divided by the sine of 33 degrees is going to be equal to 15 divided by the sine of 100 and 12 degrees. Now, my recommendation for GCSE and A-level alike is that do the first. So do the rearrangement first. So you go BC is equal to 15 sine of 30. So rearrange it first like this. We can put this in our calculators. So as I said, y BC, so the sine goes to the other side. And then I'm going to share my calculator with you so to show you how we write this. So stop sharing this. I will share a calculator. What is my calculator? Okay. Sorry. So my calculator should be here. Doesn't want to appear for some reason. My calculator. Okay. Here we are. That's my calculator. Okay. So as you can see, we can just type exactly what we have in there. So I've got a fraction. Make sure that your calculator is in degrees. So we've got that, and we can write 15 sine 33. And at the bottom, sine 112. 112. And that's that. So basically, it's exactly what I have on the board, whatever I've written. So you just put that, you press equal, and you'll never get it wrong. So it's 8.81. Okay. So then we've got 8.81, and of course, don't forget the units is 8.81 centimeters. So do the algebra first, put it at the end, you'll never get it wrong. Next one is about calculating an area of a triangle, but remember, I know this, that side, I know this other side, and the angle in between. So I know that for the area is a half of the sides times of the sides and the sides. So we go, so the area is a half times 6 times 7 sine of 60. And again, I've got that. We just go into the calculator. And then we just write that. So we can write, it's amazing, these machines, you can just write it like that. Natural 6 times 7 times the sine of 60. And now that will give us an exact number, 21√3/2. And then you press the S to put it as a decimal. And it's 18.19. So if we just so it's going to be 18.19. So we're rounding it so to 2 decimal places. .19, and this should be the area should be centimeters, and is to 2 decimal places. Okay. The next example now is asking me to calculate the size of the angle ABC. Now, when the angles are given by that, so that angle ABC, they want me to find this angle here. So what do I know A, I know the opposite, I know 20, and I want to find out the opposite. So opposite type of situation is not quack, it's not, we want to find that angle. So we can use this. This is a sine rule case. So This is sine rule. And because I want to find the angle, remember that I can write the sine of B divided by 20. So I can write the sine of, because I want the angle, I'll write up is equal to the sine of 60 divided by 18. So again, where we write sine of B is equal to 20 sine of 60 divided by 18. And here, what we can do, if you look into your calculator, in the same button that you the sine, if you press shift, you got the sine -1. So when you've got the sine, when you want to find whatever is inside, you can do B is the sine -1, and then it's 20 sine 60 over 18. So for example, know that the sine of 30 is a half. If you go on your calculator and you do the sine -1 of a half is 30. So sine is the angle that has that sine. So sine -1 of a half is the angle whose sine is a half. So and this is a very efficient way, because we won't make any mistakes. So if we do it that way, so we go into the calculator and we just type that as we've got it there. So we can just write. So remember, so your calculator, it will be in the cell, go shift sine -1 is open the bracket, so close the bracket, so we don't go wrong. And we've got a fraction. So open bracket, close bracket, and we just write exactly, I'm going to write exactly what I've got there, 220 sine 60. Remember, I open the bracket, close the bracket, so I'm going to write it exactly as I've got it in there, is 18. So we do that, and that gives me 74.2. Okay, so that is 74.2 degrees. Just a couple of tips on how to use the calculator. So make sure that you know how to go from there to that, then you can put that in the calculator and you'll never get it wrong. And then for this case, in which we want to find the length of BC, but in this case, I'm going to use a thick line and red just because I can. So you can see I know that one and I know that. So usually I say to my students, my camera there, I go like this, quack quack. So when you know that and that, a quack quack case, so is the cosine rule. So this is a case of using the cosine rule, and then in the cosine rule, this is we're gonna call this, for example, this is C, and this one is the opposite B. Okay, and this is little a. So remember that square. So BC squared, BC squared is going to be AB squared, so it's going to be that one, 23 squared plus 20 squared, and then minus twice 23 times 20, the cosine of 55. So remember, is the 23 and the 20, and then you got the cos of 55. Again, be very, very efficient if we take a square root both sides. If we write BC is the square root of all of that, if we write it like that, we will never get it wrong. So if we write that exactly in our calculator, as I'm going to show you now, you'll never get it wrong. So let me show you how we write this in the calculator. So what do I want to write? I want to write square root and all that inside. So I'm just going to write exactly what I've got. I've got 23 squared plus 20 minus twice times 23 times 20, and then the cos 55. Just be careful that we've got exactly the same as I've written down, and then put equal, and then I've got 20.03. So BC is 20.03 centimeters. So I'm going to put it in. Okay, I'm going to just so it's just some tricks to be able to do these calculations without many mistakes. So finally, this is the other thing that people were asking me is about bearings. So a bearing is a clockwise angle from north. So basically, when they're telling me that it's a bearing from A, we put the arrow in the ground. So it's almost like we're putting something in the ground. So because it's from bearing A, we put the arrow there. So this is going to be our north. So I'm putting the protractor there. So it's the angle that is clockwise. So what I'm doing is I'm going to put it in there. Okay, so arrow is probably too big. It's too thick. So it was just for emphasis. So we put it there and we put the protractor. So remember, it's clockwise. So the 0 is there. So I look all the way around there. And you can see that angle 0, 10, 20, the angle that I'm reading here is this angle is the angle 110 degrees. So a bearing is a clockwise from north. So when it says a bearing from a point, I need to put the north in there. And usually we write it as 3 figures. So this bearing will be 110 degrees. So it's just clockwise. So that is what a bearing. The most important thing is that if they tell me from A, that is what I'm going to put my arrow. Okay, so this is a typical GCSE question. So we got the map of this island, and the question. Sorry, let me just make this a little bit smaller. It's a little bit too big. So I'm going to make it a bit smaller. So we can see that the question there. So it's asking me how far the helicopter is flying. Okay, so all we need to do from leak to down, and then, sorry, let me just put here, is write down the bearing of Dumphampton from leak. But anyway, so how far the helicopter fly? So in the scale, all we need to basically measure. So so we put just so we're measuring from there, and then we're just going to see how far that is, and that is about 10 centimeters. So I'll just measure there is 10 centimeters. So remember that 1 centimeter is 10 miles, so 10 centimeters is 100 miles, and that's the distribution on bearings. Now, the next question is write down the bearing of Dumphampton from leak. Okay, so because it's saying that is from leak, what I need to do is basically is from leak. So leak is what I'm going to put my arrow. So I'm just going to put my arrow. I'm going to put my arrow in leak. So that is where the north. Okay, that is where that's where the north is. Let me just. It's not very vertical. So let me just write a vertical arrow there. Okay, so that is the north. Okay, so this is the north, and then is the bearing from leak of Dumphampton. So it's from leak. So I'm just going to join leak with Dumphampton there. Okay. So the bearing is the angle from north. So I need to measure this angle here. And for that, just going to get my protractor there. So remember that I'm going to just is from north. So I'm going to put it there. So remember, I'm measuring the angle from there, put my protractor there. Okay. So if I look at the angle from there, so it's starting at 0, that's 40. So remember, that's 90, that's a quarter of a 10. 100, 110, 120. And that seems to me 131, 230. That angle measure there, remember from 0 all the way there, is 132. Okay. 132 degrees. So that's the way we measure. So the important thing is from leak, I put the R leak. So that would be the bearing will be 132 degrees. Okay, let's do another one of these. So here we've got two houses, and it says the bearing of B from A. So from that means that I am measuring from there. So that's my north. Okay, so remember that I'm measuring from there, from A. So it's B from A. So from A means that. So you're gonna get my protractor over there. So it's clockwise from north. So I put the center of the protractor, and then I've got is clockwise. So I've got 0, 10, 20, 30, 40, 60, and that is 71, 2, 3. So that is 70, 73. Okay, so that is 73 degrees. From north, the bearing is 73. Okay. Just move that protractor away. So that is 73. So this angle here, we measure it, is 73. And then it says another house C is on a bearing of 107 from B. Okay, so it's a bearing from B. So because it says it's from B, now the north is at B. So I'm pinching there, I'm putting the arrow on B. So it's a bearing of 170 from B. I need to measure 170 degrees clockwise from B. So just gonna move my protractor. So I'm going to measure. Okay, so I've got. So remember, clockwise from north, so that's 0. I've got 40, 60, 70. So I go all the way to 170. 170 in. Okay, so that should be 170. So indicated there. Sorry, let me just. So 170 and just so it's there. 170 is in there. So that's the direction. And then what I do is I'm just going to. So that was the direction that is pointing, and then I just got my ruler. Well, you got the ruler. I can cheat with my line there. So I just do a line from there to that angle. So that is an angle of 100. So that angle here, so that angle that is 170, which you can see is nearly a straight line. It's nearly 180 degrees. And then what we have to do is on the map, C is 5 centimeters. So we get we're going to measure 5 centimeters. So okay, so from there, so 5 centimeters is there. I mean, you can do it better with a ruler. So this is the cross, and that is C. Okay, so I hope this is helping you to use tractors and things like that. This one here, you've got a boat B and a dock. So 1 centimeter is 2 kilometers. And it says work out the actual distance between the dock and the boat. So how many centimeters this is. So let's just move. If I measure from 0, that is 6.5 centimeters. So 6.5 centimeters. But remember that 1 centimeter is 2 kilometers. So 6.5 centimeters times 2 is 13 kilometers. Okay, so that is just working with the scale. Put in there, so it's 13 kilometers. And then the bearing. Measure the bearing of the boat B from dock D. From the dock D. So if it's asking me from the dock D, from means that this is where the arrow is. So my arrow is in there. I need to measure this angle. Okay. D is, that's the arrow. So I just get my protractor. I go maybe that's too big. I'm just gonna. Okay, maybe that was. So that's that. So I mean, so I put it there. Remember that I put the center of my protractor there. That's my north. Look at that. So that looks like so it is 112. Yeah, about 112. So that is at and 12 from north. Okay, so remember that's the way we measure the bearing. Okay, and then here it says find the bearing of Ballyclare from Antrim. Remember it says from Antrim. Then what I need to do is to put an arrow, a vertical. So that's my north. Oh, that's it. So it's from Antrim. Let me place the arrow. That's it. So it's the arrow is in there. I put the arrow there, and then so it says from Antrim. So from I'm gonna now join Antrim with Ballyclare there. So the bearing that the F is this one here. Okay, is that angle measure from north. Remember my 0 is there, and it have to be an obtuse angle. So it's going to be an angle that is bigger than 90. So maybe that's too big. Is it too big? That seems more. So let's put it like that. So that's 90. Okay, so 90 there. Remember, put it right in the middle. And you can see that that's 140. See if I can. 140. That's in between, so it's 145. Let me see if I. Yeah, it's 145 there. So is 145. And then it's me now the bearing of Antrim from Ballyclare. Okay. So the important thing is to know what angle is the one I'm after. So is from Ballyclare. So that means that I want it from. So I want this one in here. Okay. So Antrim from Ballyclare, it means that the north is here, and you can see that this angle now is a clockwise. A reflex angle is going to be all the way there. Okay, so it's going to be an angle that is bigger than 270, 90, 180 to 70. So it's going to be 300 or. So what we can do when we have to find a reflex angle is actually easier to measure the acute angle there. We can measure that angle just to practice that. So we can measure that angle there. So we can maybe put it there. The angle there. So remember, we're starting from 0, 10, 20, 30, 35. So this angle inside there is 35. So the bearing remember, is the clockwise, so the bearing is going to be 360. Take away 35. So that is going to be 325. So that reflex angle is that bearing, about 320. Okay, so basically this is we come to the end of the session. So this is being recorded. So hopefully you found this useful. If you would like to finish to put in the, if you would like to put in the chat anything that you would like me to do in the next, I'm going to be doing transformations of graphs, intersections of graphs, anything like that. I will be doing it in the next session. If you have any requests, can you please, before you go, let me know what you would like me to do, and you found this useful, anything that else that you would like me to do. If you can do that before you go, that'll be great. Thank you for your attention, and just please let me know what would you prefer for me to do next time. Okay, so I'm going to stop recording now.